Okay. Section 3, Topic 4, Graphing and Writing Piecewise Defined Functions, Part 2. So this is more of the same what Topic 3 was, okay? Piecewise defined function can also be written from a graph. So they can give you a function and you can write the graph, or they can give you a graph and you'll have to write the function from the graph. The graph of a piecewise defined function is given below. In order to write the function represented by this graph, we must examine each piece carefully. How many pieces will form the piecewise function? How many pieces do we have? 2. Interval A, and interval B. The right side says both A and B are what kind of functions? Linear. They were both straight lines, right? So they are linear functions. This means that both equations can be written in the form y equals mx plus b. At which x value does piece A begin and where does it end? -1 to where? -1 to negative infinity, right? Exactly. So piece A, it starts at -1 and goes all the way to negative infinity. So begins at -1 and ends at negative infinity. What does the closed circle tell us about the domain restriction for piece A? And piece A, domain would be -1, right? The range is the 3. The domain's -1. So it tells us that piece A includes -1 in the domain. At which x value does piece B begin and where does it end? Piece B begins at -1. We know it's not included, but that's its starting point, right? And it ends at positive infinity. What does the open circle tell us about the domain restriction for piece B? Exactly. It does not include -1, but it starts at -1, right? So it does not include -1, but it starts at -1. Write the piecewise defined function represented by the graph. Okay. So, we know it's like f of x equals in a bracket, right? Let's look at interval A. So, we know when we have a line to write the equation in slope-intercept form, y equals mx plus b, we need to know the slope and the y-intercept, correct? Okay, so first of all, what would the slope be for this line? You have a rise of 1, a run of 1, and is it a positive? It's negative. If it's decreasing, it's negative, right? So we don't have a y-intercept, but what would we have if this would have continued? 2. So that equation is y equals, is it x? Negative x, because your slope's -1, so negative x plus 2. But when we write the function, we already have the y equals or the f of x over here, right? So we just have the negative x plus 2 when we have to define the domain. So what is the domain for that function when x is what? less than or equal to -1. All of my x values are going to be less than -1 or equal to -1. So when x is less than or equal to -1. And it's important that you put the or equal to part because -1 is included as a domain. Okay? Is that okay with everybody? Let's look at the other interval B. What's the y-intercept? The y-intercept. 1. And the slope is what? It increases by 2. There's a rise of 2, a run of 1, right? And is it positive or negative? Positive. So if my y-intercept's 1 and my slope is positive 2, my equation would be y equals 2x plus 1. Slope of 2, y-intercept of 1. When my x's are greater than -1. We can't put the or equal to part because -1 was not included in that interval. Okay? Everybody cool with that? What is the domain of the function? All real numbers. What is the range? Y is greater than -1. Does it include -1? No. Okay. So domain is all real numbers. I'm going to be fancy and say x such that x is an element of all real numbers. And for the range, since I use interval notation above, set notation above, I'll use the same. I'll say y, because range is y values, y such that y is greater than -1. You want to use interval notation, you can do that. Everybody cool with that? Let's look at the try it. The graph of a piecewise function is given below. How many pieces do we have? 2. What kind of functions are they? Linear, right? Write a piecewise function that represents the graph. Okay, so we know we have f of x equals in a bracket, and we're going to have 2 different pieces. So let's look at interval A. What is the slope of interval A? -1? Of A is -1. From left to right, are my y values increasing or decreasing? They're going up, so it's you left to right. Is that a positive slope or negative slope? We know when the right side of a line is pointing up, it has a positive slope. When the right side of a line is pointing down, it has a negative slope. This is just a piece of this function. I don't care where the arrows are going, okay? From left to right, is it pointing up or down? If it's pointing up, it's positive slope. So what's the slope of A? +1. What's the y-intercept? 0. So that would be y equals -1x plus 0. Would we write -1x plus 0? What would we write? Y equals just -x, right? But they already have the y part, because you're not going to write -1x. I did.
Oh my gosh.
Sorry. Y equals +x plus 0. We would just write y equals x, right? Y-intercept is 0, slope of 1. Sorry about that. Try to get the next one right. When x is what? less than or equal to 0. All of the x values for that function are 0 or less than that. Okay, let's try the next one. B. What is its slope? You say 3? Looks about right. Rise of 3, a run of 1. And what's the y-intercept? 2. So what would that be? How would I write that? Y equals 3x plus 2. When x is greater than x is greater than 0. You're looking at your x values. It has an x value of 0, right? But 0 is not included, so we don't put the or equal to. Everybody cool with that? Anybody have any questions? Okay, so they both have positive slopes. They both have y-intercepts of 0. But they are not, or I'm sorry, they don't both have y-intercepts of 0. They both have positive slopes. I just need to re-record this whole video. But I'm not going to, okay? We're going to be mistake-free from here on out. Part B, what is the domain of the function? What is the range? What's the domain? Domain is all real numbers. Or I'm going to say x such that x is an element of all real numbers. Is the range going to be all real numbers? There's a gap. So from our range from negative infinity until 0, unioned with, think about that as and also, unioned with from 2 to positive infinity. So I'm going to use interval notation from negative infinity all the way to 0, and I'm including it because it's the range, and 0 is included on that interval. Union from 2, parentheses, because the 2 is not included, all the way to where? Positive infinity. Yay! How do you know that the graph represents a function? Is it a function? Yeah, yes. It has to be. If we use this function notation, it's got to be a function. Because it does what? What does it pass? Passes the vertical line test. Or there is no repeating domains. Every x value has one y value. So I'm just going to say will pass the vertical line test. Or does pass. Any questions on that? Graph the following. This is a beat the test. Graph the following piecewise defined function. Okay, so we just look at the different rules for different values of x. We have 3 pieces. The top one, what kind of graph is that? Quadratic. It's 2 degrees. It's a quadratic. We're going to use this piece when x is less than or equal to 0. So I'm definitely going to use 0 is my starting point, -1, -2, -3, and see, I'll go from there. So 0 squared is 0 minus 1, -1. -1 quantity squared. +1 minus 1 is 0. -2 quantity squared. 4 minus 1 is 3. -3 quantity squared. 9 minus 1 is, alright, so let's see what we have. When x is 0, y is -1, and that is a closed circle because my domain includes 0. When x is -1, y is 0. When x is -2, y is 3. When x is -3, y is 8. And that is curved. It's quadratic. It's a curved function. It's not straight. Mine's a little off. Make my little point bigger. So what kind of function is the next function? linear. And we're graphing that function when I have my domain is between 0 and 2, not including 0, but including 2, okay? So I will use 0 as a starting point, and I'll do 1 and 2, and I know it's a line, okay? So I'll start with 0, 1, and 2. Of course, you could use decimals if you wanted to. When x is 0, 3 times 0 is 0, 0 minus 2 is negative 2. When x is 1, 3 times 1 is 3, 3 minus 2 is 1. When x is 2, 3 times 2 is 6, 6 minus 2 is 4. So when x is 0, y is negative 2, and it will be an open circle. It does not include 0. When x is 1, y is 1. When x is 2, y is 4. Now, while I put arrows on either ends, no, because it's only for x values between 0 and 2. And that 2 should be a closed circle. So it's just basically a line segment, yes. It has no x values unless they're between those points of 0 and 2. And when x is greater than 2, y is 4, okay? So x would be my starting point. 2 would be my starting point. Give me some other values when x is greater than 2. 3, 4, 5. So when x is greater than 2, y is 4. That means all of these have y values of 4, all the way to positive infinity, right? So when x is 2, y is 4, and that there's already a closed circle there, but this one's open, so I just put it around it. So it's included on my linear piece, but it is not included on this piece, okay? When x is 3, y is 4. When x is 4, y is 4. When x is 5, y is 4. So this is just a piece of a horizontal line. And I will put an arrow to the right of that because it keeps going to positive infinity. So I have 3 pieces there. Everybody cool with that? You have any questions? What's my domain? All real numbers. What's my range? Y is greater than, what'd you say? Negative 2. Is this function increasing or decreasing? Decreasing. Don't look at the arrow. Look at your y values from left to right. What about this function? What about this function? It's neither, right? It's remaining constant. Okay, one more little section, one more little part. The following graph represents a piecewise function. Part A, write a piecewise function that represents the graph. So for this first section, what do you think that is? Y is equal to 4 when what? X is what? Greater than negative 6? But less than or equal to negative 2. So we would write that like that. The starting value is negative 6, not included. Negative 6 is less than x is less than or equal to 2. If you put the x in the middle, then these signs are both less than, and then you would put the or equal to if it includes it. So when I read this, I say x is between negative 6 and 2. Or negative 2, thank you. Negative 2. X is between negative 6 and negative 2. Does not include negative 6, but it includes negative 2. Thank goodness you're here. I do. All right, how are we going to write this part? Y is equal to x squared. That's a parent function of a quadratic. Okay, we haven't really graphed quadratics much this year, but that is just a parent function. I know that because it has a vertex of 0, 0, has a point at 1, 1, 2, 4, so I know that's a parent function. So that is just x squared. For any value of x, doesn't it only have values of x between these 2 points? Right? Has it -2, -1, 0, 1, 2, or 2, and then it stops there, right? So it has values of x between -2 and +2, and it includes both of those points. And then what do we have here? What kind of function is that? Linear. And what's the slope? -1. Nice. What would the y-intercept be? 6, but it's not, but that we would still, it's part of the function, right? Because if I did include that, I would think the y-intercept was at 0 if I didn't put anything. So our slope is -1, so we just write -x. Our y-intercept would be +6. When x is greater than or equal to 2. Very good. Because all my x values are increasing as I go to the right. Oh, wait. That's not an arrow there, right? It ends at 6. So we should say yes. So that's not actually an arrow. This arrow is going for the x-axis. This segment ends right there. Part B, which of the following statements are true about the graph? Check all that apply. F of x equals x squared, where -2 is less than or equal to x is less than or equal to 2. Is that true? Yeah, we even wrote that was part of the function that we wrote, right? So we would check that box. How about the quadratic graph has a maximum at 0, 4? Nope. The graph has an undefined slope when x is between -6 and -2. That's a tricky one, right? A vertical line has an undefined slope. A horizontal line has a slope of 0. Because you have a rise of 0, a run of 4, so that would reduce to 0. So horizontal has a slope of 0. Vertical line has an undefined slope. That was a tricky one. The graph is decreasing when the domain is between -2 and 0, and also 2 to 6. That's true, right? From -2 to 0, isn't it decreasing? And also when x is 2 all the way till when x is 6 is decreasing. So that is true. The range of the piecewise function is when your y values are between 0 and 4 and includes 4. Is that true? Yes, it is. Just talking about your y values. Oh, and it also includes 0. Just talking about the range, that's your y values. The domain of this piecewise function, so your x values are between -6, including -6, all the way to +6, including +6. Exactly. So close. If it did not have the or equal to part, that would be true, right? But -6 is not included. That's just a starting point. Okay? Is everybody good with that? These are not difficult. Some you just very particular about things. So sometimes you just got to think about it a little more and don't get your x's and your y's mixed up. Okay?